Sample 1 says a pipe of non-uniform diameter carries water. At one point, the pipe is a radius of 2 centimeters. And the flow speed is equal to 6 meters per second. And what is the flow speed at point where the pipe constricts to a radius of 1 centimeter? What is the flow speed? So V2 equals question mark. Alrighty, we check back in our notes. What equation do you see that relates size to flow speed? Pressure on the left equals pressure on the right. What could we rearrange that equation to? So pressure left equals pressure right. Does that create the AV? Is that the source for this one? We have radius. Can we get a cross-sectional area though with the radius? Can you get an area of a circle because you have a radius? Yeah. Okay. Glad we're on the same page. 1, 1, 2, 2. Why don't we just rearrange it first? My brain's working in that mode. A1 V1 over, we want V2, right? So A2 equals V2. I'm just going to plug it in. Wait, pi r squared times 6 over pi r squared. What cancels? Pi. Also, if I change the units to centimeters, if I move this over by 0.02 and then this becomes 0.01, is it going to change my answer? No, my units cancel too. For the distances or areas. 4 times 6 over 1. 4 times 6. 4 times 6 is 24 meters per second. Number 2, if the diameter of a pipe increases from 4 centimeters to 12 centimeters, I feel like this is pretty much the same problem, just a different diameter change. So I'm going to go ahead and skip number 2 and move on to number 3. A side of an above ground pool is punctured and water gushes out through a hole. If the total depth of the pool is 2.5 meters and the puncture is 1 meter above the ground level, what is the efflux speed of the water? Do we have a named theorem that we can just write down? Okay. Torricelli? I think of vermicelli.
I thought it was Torricelli.
I mean, some people say vermicelli, so we wouldn't be wrong. Maybe it is Torricelli. Vermicelli, vermicelli, Torricelli, Torricelli. I am recording. Yeah, you get this. You get this if you listen to it back. Our rambling. What's the equation? 2 G H. Wait, 2 is a constant. What's G? A constant for this planet. And our change in height is 1.5. That's so easy. If that appears on the test, it's like cheating. Because it's a named rule, so I don't see why we can't put it down. 20 times 1.5 is about 30-ish. And we take the square root about 30-ish. So we get 25, a little more than 25-ish, 25.5. 25 point what? 25 point. Oh, 5. Sorry, I'm doing the square root of 25 first. 5.422 meters per second. Good. My brain's thinking between the square root of 25 and square root of 26 is what my brain is doing.